So when you talk about the homogeneous differential equation, number one is to actually identify when is the equation homogeneous. Now, lots of times you will not be mentioned that solve the differential equation. I mean, using a particular technique. So it's up to you who has to figure out when the equation is homogeneous and when it is not. So generally, I mean, when I make the dy by dx the subject of the formula, like for example here, let's say dy by dx, if I make the subject of the formula x squared plus 3xy plus 2x squared over x squared. Now, when you look at this part, where first easiest way to recognize is that each term collective power should be the same. Like here you can see there is 2, then there is 1 and 1 here. So combined power is 2, once again 2, and once again 2 in denominator. Now, what if equation was something like this, like 3x cubed plus 2x squared y plus 4x over x to the power 3. So even though all the terms are having the collective degree of 3, you can see 3, 2 and 1 is 3, and here the degree is not 3. So this won't be a homogeneous equation. So also one of the interesting fact is if this happens where the collective degree is the same, then dy by dx can be written as a function of y over x. So let's see for this question, if I isolate, it'll be x squared over x squared plus 3xy over x squared plus 2x squared over x squared. So when we do so, what happens is this is actually y squared. So this is y squared here. So now I can see this is y over x the whole square. This is once again 3 times y over x and plus 2. So you can see that I could write down the derivative as a function of y over x. And this is the, you can say, the main specific feature about um, the, homogeneous differential equation. Now, the strategy to solve such equation is very simple. Okay, we try to make wherever you have y over x, we try to take some other variable and try to reduce into something which is much integratable and easily doable form. So let's say if I have, if I make the substitution as y over x equals to v, instead of taking y over x as v, we can also sometimes write down this as taking y as vx. Now here, v is not a constant. V is another variable I'm taking, and so we need to differentiate this. We need to replace this dy by dx in terms of v now. So how do we do that? So number one is you can apply the product rule on this. So dy by dx equals to v times derivative of x, which is derivative of x will be 1 plus x times derivative of v. So it'll be v plus x dv by dx. So wherever you see dy by dx can be eliminated with this expression. So this is actually got to remember it. If you can, like, remember in your um, exam time, you can much easily, like, complete the problem well within the time. So let's say v plus x dv by dx goes out here. Now, why it is important is because if my right hand side is a variable of v, is in terms of variable v, what happens is that if I don't change that variable uh, differential in the left side, it will be incorrect. You can't integrate it. So that's why d instead of dy by dx, because y might disappear, your integration has to be purely in terms of v. So now when I do that substitution, let us see what happens if I make in place of y, if I put vx. So dy by dx will be replaced by v plus x dv by dx equals to, in place of y, we're going to put vx will be v squared x squared. In place of this y will be 3x times vx plus 2x squared over x squared. Now what you'll notice is that x squared get cancelled if you take common. So if you take x squared common, you're left with v squared here plus 3v here plus 2 over x squared, and this get cancelled. And after this, what we have is we bring in v other side. So it'll be v plus x dv by dx is going to be v squared plus 3v plus 2 Bring in this v this side, so it'll be x dv by dx equals to v square plus 3v plus 2 minus v. So as a result, this will get v square plus 2v plus 2 x dv by dx. Now after this, we have to follow the separation of variable technique. So let us do that part. So when you're doing the separation of variable technique, we are gonna write down it systematically. So x dv by dx, let's say x dv by dx equals to, we have got v squared plus 2v plus 2. And what you do is basically you're gonna um, bring in v terms one side, so dv over v squared plus 2v plus 2 equals to dx over x. Now when you integrate both the sides, the right hand side is obviously ln x plus c, and the left hand side is something that needs to be thought well. So now v squared plus 2v plus 2, like first thing that you can think of is that it is not factorizable. So how can we integrate this? So obviously, what I use is integration of this logic. A squared plus x squared integral is 1 over a tan inverse x over a. So what we do is when I integrate this, I just make it v squared plus 2v plus 2 as a perfect square term. So if I integrate this, it'll be dv over v squared plus 2v plus 1, and I splitted this 2 as plus 1 and plus 1. So this part is actually integration of dv over v plus 1 the whole squared plus 1 equals to ln x plus c. Now what happens is this part will basically become integration of dv over 1 plus v plus 1 the whole square, which is, if you compare a square, so a is 1 and x has been replaced with another linear function, which is like v plus 1, means v has been replaced by another linear function. So this integral is going to be 1 over a, which is 1, tan inverse v plus 1 over 1, which is tan inverse ax plus b. So here I'm doing is integration of 1 ax plus b the whole squared plus like c squared will be something like this is 1 over c tan inverse of ax plus b over c divided by coefficient of x, which is a. Don't forget to do or remember, don't forget these stuff. So 1 by 1 tan inverse v plus 1 upon 1. So this will become basically ln absolute value of x plus c. And then you solve for tan basically. So v plus 1 equals to tan of ln x plus c, and you can find out the constant now obviously, and v is nothing but y over x, so y over x plus 1 is this, and if you make y the subject and then you plug in x is 1 and y is negative 1, you're going to get the constant, the value of the constant c. So that's how you integrate this particular question using homogeneous. Don't forget to use this stuff towards the end, because this carries maybe around 3 to 4 marks. So you plug in x equals to 1 and y equals to negative 1 to get this constant of the integral. So yeah. So once again, as you can see here, that this is a function of derivative being a function of y over x, hence it is a homogeneous equation. So now overall the substitution is y equals to obviously vx here, so y equals to vx, and in place of dy by dx, if I differentiate this using product rule, so it'll be v times 1 plus x dv by dx. So just remember this substitution. In place of dy by dx, we can replace with v plus x dv by dx. So now you put it out here in place of this x value, dy by dx. So we're going to get v plus x dv by dx equals to, and obviously y by over x is v, plus v square, and this v and v get cancelled. So what we get is dv over v squared if you separate the variables, and dx over x. If you integrate both the sides, and here the problem has been given is when x is 1, y is 2 in the beginning, to get the exact equation. So this integral will be integration of v to the power negative 2 dv equals to ln x plus c. Now this one will be v to the power negative 1 over negative 1 equals to ln x plus c. You can just multiply this negative other side. So 1 over v equals to negative ln negative c. And so now I can plug in the, let's say this 1 over v is nothing but, if I reciprocate this, v will be 1 over negative ln absolute value of x minus c, and v is nothing but y over x. So 1 over negative ln absolute value of x minus c, and if you multiply x here, we get final integral will be y equals to x over negative ln absolute value of x minus c. Now out here, plug x is 1 and y is 2. So when I plug x is 1 and y is 2, so what we get is 2 equals to x is 1 minus ln 1 minus c. So what we get is this part becomes 0. So 2 equals to 1 over negative c. So you get c is negative half. So that's the exact constant. And so hence my function becomes, the function is y equals to x over negative ln absolute value of x minus half will become plus half. So that's the exact function that we have got out here.